Hello students, welcome to the online class. In our previous class, in the first session, we have seen some important points. What are they? Motion, rest, relative motion, uniform motion, non-uniform motion. And in this class, we will learn some other types of motion. What are they? Translatory motion, rotatory motion, oscillatory motion. And then after we will compare the slowness and fast, and then after we will see the time, what are the devices that we use to measure the time and what are the units of time is, and then after we will see important topic speed also. So, let us get started with the first topic, that is types of motion. Okay. In that types of motion, the first one is translatory motion. What is this translatory motion? If you observe the train, it moves along a track, it is a straight path. When bus takes turn, it moves in a curved path. Yes. So, what type of motion all these? One object is moving in a curved path and another object is moving straight. Can we name these motions? Yes. We can name these motions as translatory motion. Yes. And this translatory motion also, it is classified as two types. The first one is rectilinear motion and second is curvilinear motion. So, before that, let us define what is translatory motion. If all particles of your body is moving along a straight path or a curved path, then we say that that object is said to be in translatory motion. Okay? For example, if you take the train, the wheels of the train, it is moving along the straight path with the train, its engine also along the path and its bogies also along the same path. So, all particles of your one body, if it is moving along a straight path or in a curved path, then we consider it as translatory motion, and this translatory motion classified as rectilinear and curvilinear. When object goes along a straight path, then we call it as a rectilinear motion. Okay? If the object moves in a curved path, then we call it as a curvilinear motion. In our textbook, he has given some bodies of motion. Let us classify that as rectilinear and curvilinear. Let us see that. So, in the page number 31, sorry, not 31, the page number is 32. In this page number, let us see. The first one, soldiers marching in a parade. How do they march? They march straight. So, this is rectilinear motion. And second, car taking a turn on road. It is taking turn. So, it is curvilinear motion. Yes. And third one, stone dropped from a height. If it is dropped from a height, it falls straight. So, it is a rectilinear motion. And running race along a road. So, the road is straight and we are saying here along a road, nothing but it is a straight path to the road. So, this is also rectilinear motion. And fifth one, running race along a track on a road. So, generally how do these tracks? They are in a circular. Yes. So, these tracks, if they are in circular, then the persons who are running along a track, they will also move in a curved path. So, then we can classify it as a curvilinear motion. And then after sixth one, movement of bicycle on a road. Most of the times, for example, if he is going the straight, then it is a rectilinear motion. If it takes turn, then it is a curvilinear motion. So, it depends on how it is going. Yes. If you are going with the speed, high speed, then usually we go straight. In such situation, we can consider it as a rectilinear motion. If you are taking the turn, in such situation, we go slowly. In that, it is considered as a curvilinear motion. I hope you understand this topic, rectilinear and curvilinear motion. This rectilinear and curvilinear together is called as a translatory motion. So, we have seen almost 8 examples of rectilinear and curvilinear motions. And now, let us see another one, that is the second one, rotatory motion. So, what is this rotatory motion? and where we can see this rotatory motions in the objects. Yes, for example, spinning top. Yeah, I used to play in my childhood. So this spinning top, it rotates. Yes, and not only that, even in rotation of the earth also, it takes 24 hours. So that is also rotatory motion. And what about the blades of fan? So blades of fan also, it is a rotatory motion. And in cooler, that is also rotatory motion. So there are, we can see so many objects, and all the planets also, they rotate themselves. Yes, they are also in rotatory motion. So all the objects, I mean all the particles of a body, they rotate about a fixed point. Okay, they rotate about a fixed point or a fixed axis. Okay, so then we call that object is in rotatory motion. To understand this rotatory motion, let's take one diagram. So here we can see here fan, and we are taking only one blade. These are not another blades. Okay, this is here we are taking only one blade, and in this we are pointing here dots with A, B, C. Okay, these are the 3 points that are present on this blade. And now when we turn on the switch, and these blades, they start to rotate. When they start to rotate, this A point, it comes to here, A1. This A comes to the position of A1 in this way. And now this B point or B point on this blade, it comes to the point of this one. We can give it as B1 in this way. Yes, and now this C point also, obviously it comes in this way. When it is rotating, it meets at this point. So C1, and again this A1, when it rotating completely, when one complete rotation forms, then what happens? This A1 meets at this point. Let's give it as A2, and here B1 meets at this point, and C1 meets at this point. So now the same 3 points continuously in just one rotation, it is rotating in just in a circular path. Yes, these 3 points A, B, C. Okay, and every time in the same path. What is path? It's a circular path like this. Okay, and they are rotating in a circular path with a fixed point. What is that fixed point? This is the fixed point. So this we can consider it as the center of the circle, just like that. So this is the fixed point. Around the fixed point, the particles of a blade are rotating in a circular path. So then we can say that the object is in rotatory motion. If the all particles of a body is rotating in a circular path around a fixed point or axis of rotation, then that object is said to be in rotatory motion. So now how these points are meeting at this A1, B1 and A2, B2, C2. So in the same way, we can take other objects also. As I said, for example, the wheels of the vehicles. Wheels of the vehicles are rotatory motion. Yes, fan, rotatory motion, blades of fan, and spinning top, rotatory motion, and rotation of all earths, I mean all planets. So they are also rotatory motion. So this is the concept of the rotatory motion. But here one of the most important point we have to understand. What is that? Is there any difference between rotatory motion and circular motion, or are they both same? Yes, they are not same. Okay, so rotatory motion is different, circular motion is different. In rotatory motion, only the particles of a body, they rotate in a circular path, but in a circular motion, the whole body, it moves in a circular path. We'll take one clear example to understand difference between the rotatory motion and circular motion. For example, the rotation of the earth, it is rotatory motion. Yes, and that same earth, it orbit the sun in a circular path. The whole earth body, it moves in a circular path revolving around the sun. Then in this situation, we consider this as circular motion, because the whole body, the earth, it is revolving around the sun. So, this is circular motion, okay. But when that earth, though at any point, if it is rotating with a fixed point just like this, with a fixed point, then we can consider it as a rotatory motion. So, now I hope you understand the difference between the rotatory motion and circular motion. As the rotation of the earth, it is rotatory motion, and the orbiting the sun, that is circular motion. And now let us see another type of motion, that is oscillatory motion. What is this? For example, if you take the old pendulum clocks, that pendulum, it moves from one end to the another end, and if you observe the sieving machine in the sieving needle in the sieving machine, it moves up and down, up and down, up and down, and the swing, yes, it moves from one end to the another end. Even the person who sits on the swing also, he moves from one end to the another end. And what about seesaw? That seesaw also one end to the another end, in this way. So, what type of all these motions can we name this? Again, we can name this as oscillatory motion. And what is the definition of oscillatory motions? The objects which moves forwards and backwards, or which moves up and down, are considered as in oscillatory motion. The objects which moves forward and backward or up and down are considered as to be in oscillatory motion, okay. So, this is the oscillatory motion, and now we will take some examples. In our textbook, we have one activity. He has given some motion of different bodies. We have to classify whether it is a oscillatory or translatory. Let us see in this. The page number is 35, let us do 10, okay. In that, the first one, motion of blades of a ceiling fan. Obviously, we have seen that is rotatory motion. And the second one, motion of an arrow from a bow. So, it goes straight. So, it is a rectilinear motion in translatory, okay. Third one, motion of the earth around the sun. Very good. Motion of the earth around the sun, actually it is circular motion, but actually about circulation is not mentioned in our textbook. So, it is as given rotatory motion. And now, motion of a drill bit. Wow, very interesting one, this one. Why it is interesting one? The reason is that when you turn on that drill bit, it rotates, and at the same time it goes straight, that drill bit. We can observe here two types of motion in this motion of the drill bit. What are those two types? One is rotatory motion and another is rectilinear motion, which is going straight into the object. Yes, not only in the drill bit, when you roll a ball on the floor, what happens? The ball rotates. Not only just it is rotating, it is covering some distance in a straight path. So, it is moving straight and it is rotating. So, we can see more than one motion in any motion of bodies, just like in the ball and just like in the drill bit. So, drill bit has, it is in translatory and rotatory, I mean rectilinear and rotatory. Rectilinear is also considered as a translatory only, okay. And even the rolling of the ball on the floor, it is also considered as both translatory and rotatory. And now let us see another one, that is motion of wheels of an object in a vehicle, either it is bicycle or bike or any train or so whatever it is, the wheels they also have two types of motion. What are they? The wheels they rotate, so it is a rotatory motion, and at the same time the wheels they go straight or they move in a curved path. When they are taking turn, the object will move in a curved path. When that object goes straight, then it is a rectilinear motion. So, we can simply call it as a translatory, okay. So, translatory and the rotating of wheels, rotatory motion. So, simply the wheels are in translatory and in rotatory also. And now, we will see some another activity with oscillatory motions. He has given almost 8 situations we have to classify. In the page number 36, let us do 11. Check that out. The first one, a spinning top. What type of motion it is? I already told you, spinning top is rotatory motion. Second, bullet fired from a gun. If the bullet comes out from the gun, obviously it goes straight, so it is a rectilinear motion. Third one, typewriter key. So typewriter key, when we press it, it goes down, and when we leave the finger, it comes up and down, up and down, up and down. What type of motion? Oscillatory motion. And next one, motion of a potter's wheel. Very good example. So motion of a potter's wheel, it rotates just like other wheels of vehicle, same. Next, motion of a vibrating sitar string. Vibrating sitar string, it can be considered as vibratory, I mean vibrations in the string. So we can consider it as a oscillatory motion, because just when we hit that, slowly it moves up and down, up and down, up and down. It vibrates, okay. So it is oscillatory motion. And then after, motion of a car taking a turn while moving. While moving, what type of motion it is? Obviously curvilinear motion. We can next, ringing of a bell. Very good, excellent example, ringing of a bell. Have you ever observed the ringing of a bell, electric bell? It is oscillatory motion, as continuously it hits that bell, okay. So it is oscillatory motion. You will learn in detail how electric bell works in class 10. Okay, a bouncing ball. Bouncing ball, so when you drop that ball, what happens? It bounces up, down, up, down. So up to certain limit, it moves. The motion of the ball is up and down, up and down. So we can consider it as a oscillatory motion. So here we have seen the three main types of motion. What are they? Translatory motion, rotatory motion and oscillatory motion, and we have taken some examples from the textbook. We classified them as oscillatory, rotatory and translatory. And now let us see another topic, that is slow and fast. What is this slow and fast? For example, snail is moving from A to B. Let us assume the distance. This is the A point, this is the B point, okay. The snail, it is moving from A point to B point, okay. And let us assume cheetah, it is moving from A point to B point. Which will reach the B point first? Will it cheetah or will it snail? Obviously we know that cheetah will reach the B point first. Then we can say that cheetah is moving faster than snail. Yes. In our surrounding, some objects they move fast, some objects they move slowly. Not only objects, we also, sometimes we walk slow, sometimes we run, yes, to cover the extra distance in less time. So we can classify them, all these motions, into another type also, that is slow motions and fast motions. So in this textbook, here we have some situations. Let us classify those situations into slow motions and fast motions. Let us see that. In the page number 36, let us do 12, comparing the motion of objects. First one, aeroplane, train. Obviously aeroplane moves faster, train slower when you compare with the aeroplane. Remember, when we comparing with the aeroplane, train moves slower. Next, bus, rickshaw. Obviously bus moves faster. Third one, bicycle, scooter. Scooter moves faster. Fourth, elephant, cheetah. Cheetah moves faster. Fifth, dog, buffalo. Obviously dog moves faster. Man, horse. What do you say? Horse moves faster than the man. So these are some classifications of slow motions and fast motions we have seen. So let us recall what we have learnt in this class. In that first one, we have seen translatory motions. If all the particles of a body moves along a straight or curved path, then we can say that object is in translatory motion. And this translatory motion is also classified as rectilinear motion and curvilinear motion. So rectilinear motion means if all the particles of a body moves along a straight path, then it is a rectilinear motion. If all the particles of a body moves along a curved path, in a curved path, then it is a curvilinear motion. And then after we have seen rotatory motion. if all the particles, if they rotate about a fixed point or axis of rotation, then we can say that the object is in rotatory motion. And we have seen oscillator motion, the object which moves forwards and backwards or to and fro, yes, up and down. So these are oscillatory motions. We took so many examples for all these translatory, rotator and oscillations, and even we have seen slow and fast. Some objects move slow, some objects move faster. So we will see the other topics, time and speed, in our next session. So till then, bye, thank you.